The universe is an impossibly large place, and looking up at the night sky, it's only natural to ask the most profound question in human history. Are we alone? To even begin to answer that, we have to grasp the sheer scale of the cosmos. Look at these points of light. In our own Milky Way galaxy alone, there are roughly 100 billion stars. But that's just the beginning. In the observable universe, there are estimated to be 2 trillion galaxies, each teeming with their own billions of suns. Now, watch as the vastness of the cosmos fades away and we zoom in on just one single star. Somewhere in that immense void, could there be another world looking back at us? Focus on the sun and this green ring, known as the habitable zone. If a planet orbits too close, like this red sphere, it becomes far too hot, reaching a scorching 460 degrees. But as it moves into the green band, it turns blue, hitting the sweet spot where temperatures allow for liquid water. Drift too far out, though, and the world freezes over, leaving potential life locked in ice. To estimate how many civilizations are out there, we use the Drake equation. Think of it as a cosmic sieve. We start with the rate of star formation, R star. These dots represent all the potential starting points in our galaxy. But not every star has planets. As we multiply by FP, we filter out stars without planetary systems. Next, we factor in NE, the number of those planets that are actually habitable. Watch the field narrow as we sieve through the candidates. Finally, we consider FL, the likelihood that life actually emerges. Even after these filters, the math suggests that thousands of civilizations should exist. Against this vast backdrop of stars, we are searching. Down here on Earth, we scan the skies for any sign of intelligence, leading us to a chilling contradiction known as the Fermi Paradox. If life is common, we would expect to see signals like these radio pulses rippling through the void from distant neighbors. But so far, the silence is total. The logic is simple. The universe is nearly 14 billion years old. In that time, even at sublight speeds, civilizations should have had more than enough time to spread across the entire galaxy. So, with all these stars and all this time, it leaves us with one haunting question. Where is everybody? One possible answer to the Fermi Paradox is the Great Filter. Imagine the path of life as a staircase, climbing from simple cells to complex life, then intelligence, and finally, space travel. To explain why the universe seems empty, there must be a hurdle so difficult that almost no one makes it across. We call this the filter. Watch as these potential civilizations attempt the climb. Most are extinguished by this barrier, whether by natural catastrophe or self-destruction. But occasionally, a rare success emerges. This leads to a haunting dilemma. Where are we on this staircase? If the filter is behind us, we are incredibly lucky survivors who have already passed the hardest part. But if the filter is still ahead of us, our greatest challenge and our potential end is yet to come. In the vast darkness, we find ourselves looking at a single tiny blue pixel. Watch as it recedes, becoming almost lost in the infinite void. This is our home, and for all we know, it might be the only place in the entire cosmos where the universe has truly woken up. If the Great Filter is behind us, or if we are simply the first, the weight of that reality is immense. As these words appear, consider the possibility. If we are truly alone, then we are the only eyes the universe has to look back at itself and wonder. We are the way the cosmos observes its own beauty and its own laws. This makes our survival more than just a biological necessity. It is a cosmic duty. We must protect the light of consciousness, flickering here on this pale blue dot. Because if it goes out, the universe might stay silent forever.